So we got Unit 3, Lesson 4. So now we're actually putting to the logarithm part. So we've been talking about exponents, so we can talk about logarithms. Now we can talk about logarithms. Okay. Exploring the inverse of an exponential function. So in this example, we'll consider the exponential function of y equals 2 to the x. Explore the inverse of y equals 2 to the x, algebraically. One of your guys' homework questions said to do this, and you kind of ran into a roadblock of, well, how do I x root something, or how do I y root something if I don't know what that index is? Okay, and so that's a little bit of the problem that you had in your homework question. If you didn't get to that, hopefully you do. Okay, to find the inverse of a function algebraically, we must switch x and y and solve for y. So it says attempt. So if we attempt, you're going to see what's going to happen. They're pretty much asked the same question that was in your homework. So we're going to have x equals 2 to the y. And so now your question is, how do I get the y down? Times x by 2. So that would just give me 2x though, right? So I know what you're thinking. You're thinking in the sense I want to get a base of 2 somehow, right? But we can't just insert a base. We can't just make this an exponent. I can't y root something because what does that mean? Okay, so there's a problem here. Okay, so the difficulty is, just simply, guys, and just generally, the problem is, how do we get the y down? How do we get the y down? That's the problem. Okay. So algebraically, a little bit of roadblock. Let's go ahead and look at it in terms of graphically and see if we can at least see what it could look like. Okay. So we're going to do that here in a second. Okay, so move this up. Let's go ahead and look at it graphically now. Move just a little bit more so I can get the bottom there. Okay. Oh, no. Okay, right there. Okay, so determine the inverse of y to x graphically. So we switch the x and y coordinates of each of the points in the graph. Well, we can do that. That's nice because we simply can get coordinates and switch them. So that could be helpful. So the graph of y equals 2x, we know that 2 to the negative 3 is 1/8. 2 to the negative 2 is 1/4. 1/2. 1, 2, 4, 8, 16. Just plugging in those values for x, that's what you'll get. Let's go ahead and go blue here. So let's go ahead and graph that. Try to stay out of the way here. So negative 3, we're at 1/8, just barely there. Then we're at 1/4. Then we're at, oops, that's not negative 2. It's going by 2's there. So we got 1/8, 1/4, 1/2, 1, 2, 2, 4, 8. So here's the blue line. Okay, so that's what the 2 to the x looks like. The inverse of that, well, we just know we're going to flip them. So they just flip these, so we know that these values here, I can just insert in all these boxes. So I'm just flipping the x and y coordinates. Okay, so if I do that, that means we're going to have negative 3, so this is 1/8. Negative 2 is 1/4. 1/2. 1, 2, 4, 8, and 16. So now let's graph what that would look like. Do that in green here. So that means my x is 1/8 now. So that's a little different. My x is 1/8, so that means I'm just barely going just anywhere from the x here. So this is 1/2, so that's about 1/8 there. So 1/8, I'm at negative 3. So I'm down here. At 1/4, I'm at negative 2. So that's really, really close. Let's be like right about there. 1/2, I'm at negative 1. Right there. At 1, I'm at 0. right there. At 2, I'm at 1. I'm at 2. There. 8, I'm at 3. Right there. And so you kind of see that's what it looks like. And that looks good to us because why? It's definitely symmetric across the y equals x line, right? Which we expect an inverse. So we just kind of proved that it does exist. It is possible. We still don't know how in terms of algebraically. Okay? Any questions? So state the equation on a line of symmetry of the completed graphs. So that's what I just said with the red here. Just y equals x is all you put here. Definitely line of symmetry is y equals x, so we feel good. Okay? It reflected over the line we expected. Okay? Okay, cool. Ask questions. Logs are new to you guys. Okay, this is a whole new topic. Okay, so y equals 2x is an exponential function of the base of 2. The inverse of this function is x equals 2 to the y. It is also a function we are unable to write the equation in terms of y. To do this, we introduce the new logarithmic function. So, long story short, logs are inverses of exponentials, right? So logs give us that flexibility to have an inverse in terms of exponentials. So this is what it's going to do for you. And this will help you. If you understand it's the inverse, you're going to understand the pattern of logs. Okay? So let's go. Logarithmic function is the inverse of an exponential function. Just said that. Spoiler alert. Okay, the inverse of the exponential function of base of 2, y equals 2 to the x, we write as here. So this is what I want you to really, this is what we're doing today. Y equals log base 2 of x. Okay, and that makes sense that it's base of 2, right? Because we had a 2 base that we went from. Okay? So our x equals 2 to the y turns into y equals log base 2 of x. The only tricky part is a lot of people want to put the x here, but it's not there. It's log 2 of x is y. So here's the labelings, which may be even more important. Value of the logarithm, so that's the value of the logarithm, so what it equals. Okay. B is the base of the logarithm, which is the easy part. We know what the base is going to be. And then they call x the argument, or the thing that we're trying to essentially switch. Okay, so if you look here, the argument in this case is the x, right? That's what we're inversing. That's a good question. I'm not sure why they use that. So the inside of the logarithm, in this case, x is called the argument of the logarithm. I think it's more because that's what you're switching. So that's the switched, that inverse piece. So I'll try to see why they use the word argument. I haven't heard it called argument before, to be honest. Okay. I usually just think about this in my mind. I think about this as the exponent, and this is of like the equals. So like when you have, see how it's x equals 2y. So then I know it's going to be exponent equals log of 2x. No, I won't, at least in terms of terminology. Okay, we'll double check for the diploma though. Okay, it's a good thing to remember. So yeah, so to answer your question, Travis, I just know the thing that's over here is what the exponent of the inverse is. That's why, and then I just know that the base is the base, and then the other spot's the last spot. Okay? All right, so example 1. All right, so the graphs of y equals 2 to the x and x equals 2 to the y are shown. Are they shown? You guys have them? Yeah. Okay, that's good, because I apparently don't here. We know that they go like that, and like that, and then here's my y equals x line. Not sure why that's not up. That's interesting. So it says right and label the y equals log 2x beside the appropriate graph. So which one is that? So that one would be the inverse. So this right here is the graph of the log 2 of x equals y. This graph here. So again, the whole point, if you haven't picked up anything today, these are inverses. Okay, so let's look at them. They're domains. What are the domains? XCR, there's no problems, right? You can see with the arrows, they're both going to continue. Oh, I lied. Nope, I lied. Sorry. Yeah, we switch them. We got to switch them. We got to switch them. Yeah, it's XCR here, so if you said that, you're right. And let's just do this one range. This one's range is what? The exponential. Y greater than 0. So then that makes this have to be x greater than 0, right? They switch, and then it's YER. Remember, they switch. Domain and range, switch for your inverses. Okay. So then with exponentials, we know we don't have an x-intercept. So that means we don't have a y-intercept for the inverse, right? But we do have a y-intercept for the original. It's 1, and that's going to be the x-intercept for the inverse. So then how do you think, so let's just review from the warm-up. What's the asymptote for the exponential? The original. Right, and so then you know that the new one is x equals 0. Okay, everything's switched. What's up? Nothing? I see. All right, any questions so far? The basics of logarithms. Okay, let's keep hitting the pattern. All right, so example 2. The tables below show the coordinates of the points on the graph y equals 2x and y equals log base 2 of x. Okay, so here's the coordinates, which we already filled these out, right? So notice that the point 38 on the graph y equals 2 of x indicates that 8 equals 2 cubed. So we know that. This point here means that 2 cubed is 8. Okay? Now the point 83 on the graph indicates, in terms of logs, that log base 2 of 8 equals 3. Where's that coming from? Well, here's it is, right? So if I put a 3 here, I put a 3 there. If I put an 8 there, I put an 8 there. So if you evaluated log 8 of base 2, you would get 3. Okay. So what statement can be made from the point -2 1/4? So if we write that differently, you can say that 1/4 equals 2 to the -2, which we know that, right? 2 to the -2 equals 1/4. And then it says, what statement can be made from the point 16,4 on the graph y equals log 2x? We're just putting these in for x and y, guys. That's all we're doing. And we're just looking at the relationship. So we know that this would be 4 equals log base 2 of 16. So one thing I want you to point out, you'll get used to these patterns, okay? Since it's the inverse, guys, it's flipped, right? But this is what's kind of is happening. 2 to the 4th is what? 16. Okay, that's the pattern with logarithms. So they're essentially, they are working in reverse compared to before. Because we know we just do this one normal, but now we're doing 2 to the 4th this way equals that number. Okay, cool. Oh, sorry, weren't ready? Sorry, I'll slow down. My bad. All right, so let's go through these ones. So exponential forms. So we're just going to practice this. This is what you're going to have to do like on a quiz. Okay? Can you just change a log to an exponent? Okay? Because if they're not x and y, they're numbers, we are now fine, right? The reason we couldn't inverse that x, y before because we don't know how to y root stuff. But if we change it to exponential forms, sometimes it helps us get an actual value so we can evaluate, and that stays standard. We're trying to evaluate logarithms. So for example, you can't use your calculator sometimes. It's a little bit harder because your calculators always do a base of 10. Okay, because there's so many bases of logarithms. There is ways you can change that. Sometimes your calculators are newer, can just insert a new base. But you do need to know how to write logs in terms of exponents. Does that make sense? So what we want to do is that log 2 of 4, okay, so in exponential form, it'd be what? So it's like, what's the answer to what we're saying? So pretty much you're saying 2 to what power is 4? Yeah. That's it. 2 to what power is 2? Yeah. Tricky one. 2 to what power is 1? 0. Good job. You guys didn't get tricked. Good work. Okay, good. Now we're going to work backwards. So I'll tell you, it's log 2, and then what goes here, and then what goes after the equals. Yep. What's that, right? 2 to the negative 2 equals 1/4. Try that last one there. Okay, so if you try the last one, still should have base of 2. Log base 2 of 1/2 equals negative 1. The top one, oh yeah, top one is negative 3, yep. Thanks, Ty. Top one is negative 3. Any questions?
How do you write that in your calculator, like log?
Yeah, we'll talk about that later, okay, in terms of how to do. Yeah, we can talk about change of base in a little bit. Okay, so use patterns developed from the class examples to write the exponential 10 cubed equals 1,000 in log form. So that would be log base 10 of 1,000 equals 3. That one you can put in your calculator, Aiden. So right now in your calculator, if you put log 1,000 in your calculator, it'll kick out a 3. Because your calculator automatically goes to base of 10.
You say you could change your base calculator?
You can, or you can just do a change of base formula that does it for you. It's not too hard. Yeah. Okay, I know we'll go over that too. Ouch. Okay, so use patterns developed from class level 2 to write the log of this one in exponential form. So we know this one is 5 to the 4th equals 625. So we're just getting good at just converting back and forth between exponential and log. Okay. All right. Pretty much just going to summarize what we did, and we're going to hit some examples now. We'll be done. So stay with me. You guys got a lot going on here. Okay. So this stuff right here should be summarized. It's the flip of what we learned last class on Tuesday, right? So your characteristics of your graph of a log function. Your x-intercept's 1 opposed to your y-intercept being 1. There is no y-intercept opposed to being no x-intercept. Remember, it's everything flipped from last class. The y-axis is vertical asymptote, x equals 0 instead of y equals 0. Your domain's bigger than 0. Your range is all fine. Okay, so everything just flips from what we learned on Tuesday. Okay? All right. Since a log function of y equals log base of x is only defined for positive values of x, so that's important. We can't have a negative value there because remember, if we have an exponent of something, we can't get negative. Right? That's what they're saying there. Okay? Yep, everything else we're good. Let's go ahead and just get after it. Let's try some examples here. All right, so state the inverse of the following functions. Answer in the form of y equals. So we're going to state the inverse. So for example, I know this is 3y equals x, right? So the inverse is, right? So we converted it to exponential and then switched for the inverse. Go ahead and try B. That one we did, yep, but the B we have to bring it in, right?
Yeah.
So, yep, Kenny, you're good. So this one, we took the log out to get the inverse. This one, we need the log to help us get the inverse. Because this is the one where we're going to do this, right? We're going to go, well, they say y equals form. That's hard for me to do because we're back to this problem. So we need to write it with log. right? Because if I change this to a log, what's the equals part? The y, because that's the exponent. So it's y equals log base 8 of x. And so we've answered their question in y equals form. Okay? Good? What are we thinking? Okay? Convert each of the following logs from exponential, or sorry, complete the logs to exponential form. Okay, this one right here, this should be clockwork in my mind. Okay? You should just be like, okay, 7 to the 4th equals x, 5 to the y equals 15, t to the m equals b. Yeah, so this one I divide the 4 over. It'd be b to the 5/4 equals 6. Base exponent equals, base exponent equals, base exponent equals, move the 4, base exponent equals. For log form. Okay, I'll pause the video here. You try to put these in log form. Try to put all 4 of these in log form. Okay? I'm talking about making sure when you write log base of 4, make sure the 4 is down here. Your 64 is there. 3, so you have that clear difference there. Okay? Do you pull the 2 out for which one?
For D.
For D, let's get there. We'll see. No. Well, you can. You can. Yeah, you can. Log 2 of 1/8 is -3. Okay, you can pull the 2 out if you want. It would be if you want to write like that, you can. Like that. They didn't take the 2 out on here, though. Not on this one. It's not relevant. It's fine. It would be if you wanted to see a shift or pull those things out, but in this case, it's not necessary.
What you were looking for, you said, would your A be
No, it wouldn't be on this. Not in that case. We'll get to that later. That's like a whole.
Pulling that up is what?
Just simplifies it. Yeah.
What's prettier?
Sure. Cleaner. All right, last page. Okay, calculate the value of t. Okay. Calculate the value of t if log base 2 of x equals 3, then log base 2 of t equals x. Okay. So, first off, we got to figure out what x is. That's what it's telling you. So what x is going to be, it's 2 cubed. Right? X has to be 2 cubed. Do we all see that? So that means that we know this guy here, log 2, 8 equals 3. So x is 8. So now we know what x is. So we can go log 2 of t equals 8. So then we go 2 to the 8th is t. Okay, so 2 to the 8th, 256. I don't know that one off the top of my head either. Okay, so then t, 256. Just doing our exponent rules, log rules to get to the answer there, step by step. So what you can kind of see is if you know 2 of the 3 options in there, you can find the third, right? If you know 2 of the 3, it seems like you can get the third. Okay. All right, last piece. Bless you, yeah. Logarithm form y equals a b to the x. We've seen how to change the forms between exponential and logarithmic. We now need to consider to write the exponential form y equals a b to the x in log form. This can be done by using the following procedure. So this is what you were kind of asking, Leah, in terms of the a, when the a comes in place. Okay, so we can write it as bring the a over, change it to a logarithm, and then bring the a back, essentially. So I don't like it with the letters. Maybe we should do a couple examples here, but it's going to look like this. Okay, so let's just kind of talk about their process here. So the best thing they say to do is to get the exponential isolated. That's what you want to do. Okay, so we're going to get the exponential isolated, so it's going to be y over 2 equals 3 to the x. And now we're going to change it to log form. So we know it's log base 3 of y over 2 equals x. A little tricky because you have the fraction component there. Just follow these steps. It's pretty straightforward. Okay, while you're finishing that up. So if we look at b, so b, h over 7 equals 4k. So then it's going to be log base 4 of h over 7 equals k. This is all letters, just to make sure you know what you're doing. Let's go ahead and erase these two. Everybody have those? Good? Okay. Okay, so this one, just making sure you have the form. So it's going to be t over r equals s to the p. So log base s of t over r equals p. 3/2, just a little tricky. It's just you're gonna do the reciprocal, right? So 2/3 is going to the other side. So it's going to be 2y over 3 now equals 10x. And then we're going to change that. Log base 10 of 2y over 3 equals x. Just like, when you're doing square roots, right? When you do a radical, you don't write the 2. When you're doing a base of 10, you don't necessarily have to write the 10. It's assumed it's a 10 if nothing's there, just if you care. Okay, so what I'm saying is when we do, cube root, you have to put a 3 to say it's a 3, but that means square root. If you just write log and no base, that means it's a 10. Okay, all right, last set here, last set. Move it up so we can all see it clearly. Okay, change each of these back to exponentials. So we're going backwards, so we kind of see what's happening, right? So we know that the y over 3 signifies that I divided a 3 over. So that to me, that means it's going to be 3 times 7 to the x equals y. That 3 is my a, essentially. So b, 10 to the x. 4 is my a. Y equals 4 times 10 to the x. So since that's a 7 there, what? Yeah. It's going to be 1 over 7. So 5 to the x, and then this is a 1 over 7. Because to get rid of the 1 over 7, I would have times it by 7, which how the 7y got there. 5 to the x over 7? Sure. Yeah, 5 to the x over 7, as long as you don't have it like in brackets, just as long as that 7's separate. Yep. It's a little easier to see the a if you have the 1/7 there, because if I said, what's your a, you'd clearly see 1/7. If I said, what's your a here, hopefully you see that's a 1/7. That's fine. Okay, and the last one here, we got e to the x, and it's over 5. So y equals 5 times e to the x. Okay, that is it for today.